Hello, this is an example from another textbook, chapter 20, question 32. It says running red lights. It says a random digit dialing telephone survey of 880 drivers asked, recalling the last 10 traffic lights you drove through, how many of them were red when you entered the intersections? Of the 880 respondents, 171 admitted that at least one red light had been red. Part A. Give a 95% confidence interval for the proportion of all drivers who ran one or more of the last 10 red lights they encountered. Okay, so let's get out a blank piece of paper here. Let's first of all let's get our basic information here. So our sample size n is 880. We had 880 drivers in our sample. Our p hat is the percentage of the sample that said yes, the percentage of the people who said they ran red lights. And so back to the problem, we had 171 admitted they ran at least one red light out of 880. So that's going to be, wrong button here. Okay, so 171 out of 880. That's equal to, let me just get a calculator here real quick. 171 divided by 880 is 0.194 rounded off to 3 digits. Okay, so that's just a couple of initial calculations here. Let's back up for a minute and ask ourselves what exactly is our population and so forth. So our population here is all drivers. And P is the percentage of all drivers who run red lights out of the last 10 red lights. So percentage of all drivers who run, let's close this down here, who run red lights. Okay, now we're not going to know that answer. It's probably close to our sample result here. It's probably close to 20%, but we'll never know unless we actually ask every single driver in the entire country. Okay. Now, p hat, though, is the percentage of all drivers from our sample who run red lights, and that we know. That is 0.194. Okay, now with confidence intervals, I mentioned there's a 4-step process. Step 1 is check the conditions. Step 2 is decide what is that critical z-score, and that depends on your confidence interval. Step 3 is then compute the standard error, and then step 4 is do the formula, p hat plus or minus critical z score. So we put a little star to remind us it's the critical z times the standard error. Okay, let's get some blanks paper here. Let's start with the conditions. Okay, step 1, check the conditions. Is it even valid for us to do this computation? Well, is the sample random? Yes, it's random. In the original problem, it says right here, it says a random digit dialing telephone survey of 880 drivers. So yes, it's random. That's good. And next, the next thing you have to check is the sample less than 10% of the population. Well, that's a yes, because our population, go back to what our population is. Our population is all drivers. Well, we have millions and millions of drivers. And our sample size is just 880. So yeah, 880 is way less than 10% of all the drivers. So the answer is yes. Okay, third, do we have at least 10 successes? Yes, we have all together. So success is that we found someone that ran a red light. We had 171 of those. So yes, we have 10 successes. And did we have at least 10 failures in our sample? Again, the answer is yes. Um, Altogether, we had 880 people in the sample. 171 said yes, so the rest said no. So that's like 600 and something people said no. So yeah, that's more than 10. Okay, all the conditions are met, so we can proceed on to step 2. On to step 2 is, what is that critical z? So the idea of a critical z-score is you have that normal curve, and you need to know what is that z-score that gives you that middle 95%. Now, I have been saying 2 standard deviations from the mean encompasses the middle 95%, but we need to use the more accurate one for this. So that's going to be 1.96 right there. All right, just a quick reminder here. If you want 90% confidence, the critical z for that is 1.645. That means 90% of the area under normal curve is within 1.645 standard deviations of the mean. 95%, the critical z for that is 1.96, and that's what we have right here. Another common one, 99%, is 2.576. The higher confidence you need, the higher the critical z, because the further out along the edges of that normal curve need to be. Okay, so step 3. What is that standard error? So the formula here is p hat q hat over n square roots. So what is p hat? Well, let's go back up here. P hat was 0.194. Okay, so 0.194. Okay, and then what is q hat? Well, that's 1 minus 0.194. Let me just use my calculator here. 1 minus 0.194 is 0.806. Okay, divided by n. What is n? N is the sample size, which is 880 right there. Okay, take the square root of the whole thing. Okay, so on a calculator, let's just do this real quick here. 0.194 times 0.806 divided by 880 altogether is 0.01332, and the digits keep going on the calculator. It's probably 5 digits is probably good. Well, let's do 4 digits here. Let's do 0.0133. Okay, so step 4 is you put it all together. So our confidence interval is p hat plus or minus critical z times standard error. Okay, well, p hat we know is 0.1. What was it again? P hat 0.194 plus or minus z star, which is 1.96, times standard error, which is 0.0133 rounded off. Okay, so first I need to multiply the 1.96 times 0.0133. This 0.0133 is sitting on my calculator right now, so all I really have to do is just press times and 1.96. But let me just multiply here. Okay, so 1.96 times 0.0133 is 0.0261. Actually, I'll just round it off to 3 digits now so I match with my p hat here. So there's my confidence interval. So that's one way to write it, 0.194 plus or minus 0.026. And this, by the way, the 0.026 is the margin of error. Let me circle that right, margin of error. Which means that my p hat of 0.194 could be as far off as 0.026 from the real percentage of people who run red lights, at least at the 95% confidence. Now, it's often customary to actually add and subtract those percentages here. So I can go 1 0.194 plus 0.026, which is 0.194. I'm using my calculator again, plus 0.026, 0.22, and then go 0.194 minus 0.026, 0.026, and that gives us 0.194 minus 0.026 is 0.168. Okay, so then I can give my confidence interval like this, parentheses, 0.168, comma, 0.22. And that's a perfectly good way to give the answer as well. And then a third way to give the answer is in percentage form. You could say 16.8%. Move decimal point 2 places. And then this is 22%. Write the word 22%. So any way you want to give the answer is okay. Now, what does all this mean? It means final conclusion, let's put this in quotation marks here, I am 95% confident, because it's a statement about probability. I'm probably, this interval is probably capturing the p, but I'm 95% confident that the true percentage of drivers who run red lights, so the real percentage of the population of drivers that run red lights, or that's would answer yes to the question, run red lights, is between about 16.8% and 22%. Okay, so that's one way to interpret that. But I want to caution you that P is a fixed number. It's an unchanging number. If we actually had the time and money and resources to check every single driver in the whole country to get the true percentage of drivers, it's going to be a particular number, and most likely it's a particular number in between 16.8 and 22%. Okay, you can also interpret it as a success rate that's using this technique that I just did here. Doing all this stuff with various p hats from various random samples. 95% of the time, my confidence interval, whatever it turns out to be, captures the p. So I'm 95% sure that this interval has captured the p. And that is it. Thanks for watching.